Okay, guys, we're now into the next bit of this series of videos, and what I'm going to demonstrate is we've already done the insert at and discussed it. Now what we're going to do is we're going to do an insert at n at the end, a remove at the end, and a remove at the front. What this entails is usually for most linked lists, the standard is to now have what we call a rear node, and that one will be used to always point at the end of the list. And so we're going to add to the code that we've been working on, and the list manager is now going to have a node called rear. You know, we can call it end, we can call it last. Let's do last. Last is good. So it's just in here with list manager called last, but it needs to be instantiated to null. And we need to work with it in the same manner, because at the very beginning, when we create our nodes, when we initially first put in the very first node, it's going to be both the first and the last. The first node is always both the first and the last. So what we'll have is we'll have a head. And a rear, or a last. And they're both going to point to the initial first guy on the list. So let's say that that's at address 1000. So the head and the rear are going to both point to the first node on the list at address 1000. Remember, this has got its own pointers, its own next in here. It's got its own next, which is just kind of like a pointer that points somewhere. It's going to point 0 for now, and then we put a value in here. So that's what we got to add to the insert front, the add front. We got to say that the head is equal to current. Not only that, but last is equal to head. And we got to do that for each one. So when the new head is formed, we update the head, the last. This is different though. We only do last is equal to head when we first start out. This is going to be different though. So let's actually look into this. All right, so we got, let's say that we're putting a new one in, and we want head and last to be fixed right. So we get the new one in. And let's say current, or C, is pointing to that guy. Last and head are pointing to this guy, which is the first item on the list. So last needs to go here and always be pointing to the end. So let's go and look what a typical add front linked list has. We'll say, well, with last pointer update. some of this stuff isn't even really, yeah, let's just heck with it. Let's not even get into some examples. Let's just build it. I'm just like, whatever. I mean, because you can get into have fun with those templated Java-based linked lists. That's probably what we should be using. But this is fun. Let's get into what I would do. How would I get last so that it's pointing to this? Would I even do anything with it? Because when I assign the head and update the head, I haven't done anything to last. Oh, so I actually don't do anything. We don't do anything for that function. We just need to set it initially, and then if we're pushing it onto the front every time, every node, then we don't need to do anything with last. But what if, no, it's fine. If we have a remove function or an add rear, that's where this last pointer can become very useful. So let's go ahead and do that. Add rear. And the way that's going to work is it's going to have the same if statement, because what if we do an add rear first? But this is going to change. Okay, so we put in, say that we are putting one in over here. We put it in with a current. We're going to point current to it when it first comes into the loop for adding it to the rear. What we want is we want lasts next to equal to current, because current is going to come in at address, let's say 3000. Oh God, scribbles are bad. Okay, whatever. So we want 3000 here. So that this one, instead of pointing to null, points to the one that we now added it to the rear. But last needs to move up and also have address 3000 in it. Because this one we added to the rear, and it's the new last. So we could say last next equals current. Okay, we create it. Now let's do this. Let's say last set next, and this is where we send it current. So that then assigns address 3000, which current points to the new end, but not yet. We haven't gotten there to this guy, so it links it together so we keep the chain going. This is the old last. Now we've tied last next to current. We can now reset our last so that it is finally pointing to address 3000. So we use it to set this links next first to the new one. Then we update last to pointing to the new one again. And this link is, but that's still linked together. We're just adding one on the end. So then what I'll do is I will say last next current. Then we need to reset last equal to current. I think that'll do it. Let's do this. Let's do like 4 add rears and just test it and print it. Okay. Oh. Okay. Let's test it out. That's interesting. Okay, 3, 4, 1, 2. So now it's working last in, first out. And we can mix, we can do an add front. We can mix them in here, front or the rear. There's also inserting in between. But what we're going to do now is we're going to do the last two functions and then go into a user-defined data type. So let's do this. We've got the add functions. Now we just need to do the remove functions. So I'm going to go ahead and start laying those out. Void, we're going to do a remove front here. And then a void remove rear. All right. So when we remove from the front, all we got to do is say that head, because when we are removing from the front, head's going to point to this guy right here that's in the front. And let's say it's at address 111. So head has 111 in it, but this next here has 1000 in it. If we're removing the head, we want the front of the list, we want head to now be pointing to 1000. So we just need to say head is equal to head next. And then that'll store the 1000 in there because that's what head next has in it. And now head will point to the second one in. Very simple. But we only do that if head is not null. Because if head's null, we don't need to do anything. And we can just say if head. And since we have a garbage collector, guys, we don't have to worry about deleting the old head from memory. Doesn't like that. Of course it doesn't. Oh, I need to get next here. Excuse me. Yeah, because we're assigning it. We're assigning it to the next one. And so we're just moving traversing head over in the list. And then we don't have to delete. That one's simple. Oh, that should be in remove front. Oh, God. Okay. There we go. All right. Remove rear is going to kind of work the same way. But here's where we get into kind of like, oh, this is going to get complicated. Should we do this with a previous, or should we traverse the list to right before the very last one, the one before the last, and delete it? So we can add a previous function to every node. That would be kind of that would be the best way to go, and then we'd have to update everything else if we added a previous pointer inside of node. We can, because if we're removing the rear, we got to traverse, and we got to take a current traverse to here, so that we can set the next, instead of it pointing at just 3000, it points at 0. And you know what? Let's just do that. So what we're going to do is we're going to have a current that we assign to head. That current is going to be used to traverse. We're going to have head, and it's going to be used to traverse the list. And we want current to walk this list for counter how many items are in the list minus 1. That way we can set this next equal to 0 instead of pointing to an actual node. Now that's the dirty way of doing this. The clean way is to introduce a previous pointer into the mix. Now we're going to do it the dirty way because we're not going to go crazy with this. All right. So what we're going to do is we're going to have a for loop, but we're going to introduce something called a counter. Int counter, and what we need to do is we need to, every time we add, we need to add to that counter. We're going to do a counter plus plus. That way we know how many items to traverse the list for to get to the one right before the actual last, so that we can assign it to essentially go nowhere or null. So we remove it from the rear. There we go. Okay. Now we got our remove rear. And we're going to have the same type of logic. And what we'll do is we will have a current, a node current equal to the head, so that we can traverse current. Kind of messing up. I should be doing that in here. And for the amount of items in the list minus 1. We'll see if this works. And what we'll say is current is equal to currents next, get next. Use that to traverse the list. And once we're done traversing, it's really simple. We can say currents next. Okay, so what we're going to do is we're going to traverse. We're gonna traverse current, so that current is pointing. Where is my logo? Current is pointing right here, and its next is pointing to this guy. It's, you know, the next value is pointing here, and let's say that it's at address 1000, and so that's what this next pointer is holding. We want to assign it 0. So it's pointing nowhere, so essentially gets rid of this guy. And then we want to reset last to current. So the current and last points to the one right before. Okay? So current dot next, we want to set is equal to current dot get next. So we traverse the list. That's what this loop does. Get to the one right before the last. We say it's next. So current's pointing here. We say it's next is equal to its next, which is this guy. Oh no, we say it's equal to 0. Whoa, I'm being silly. Okay, current dot. Once we get there, we say current dot set next. And it's going to be current. No, it's going to be 0. 0. Or no, excuse me. We got to use proper terms. Even though null is just 0 down deep. Okay. That essentially deletes it from the list. But I need to then assign last equal to current. Okay, that's our remove rear. Now, oh, don't forget this. It looks like I'm off by a thing. And then I got to do current minus minus. All right, we might have a fence post here. This might traverse over a little bit, but we'll... Oh, what am I doing? Counter. Current. Oh my God. Counter. Okay, there we go. That's our remove front and our remove rear. Now let's test it. All right, so when we print this, what is at the front? 3 is at the front. So let's do this. Manager dot remove front. So the 3 should be gone now. 3 is gone, so that's good. All right, now let's remove the rear. Okay, let's see. Yeah. Remove rear messed up because current is null at some point. Oh. Java, what a turd. It should... All right, for some reason, we are going over, our counter is not working. So something wrong with this. Oh yeah, I'm an idiot. No wonder current is going null. Because I'm incrementing counter in the loop. Oh my God. Okay. I bet you there's some giggling going on. I'm such a silly goose. Okay. Counter -1 to right before, traverse, and then do the duty, the job. Let's go back here to this. And let's run this. 4, 1, 2. So 2 is not being removed. Now let's look into that. Let's go in and go into the list manager, and let's set a breakpoint for remove rear. And let's see what's going on. I think I'm probably gonna have to set the breakpoint. Why is it running you? NetBeans is being really weird right now. I just brought that up and ran it instead. Okay, maybe I should do that. Yeah. For some reason, it's just going into a weird debug mode. Okay, this is really interesting. Okay, okay, there we go. I just want to stop there. Okay, I got it in debug mode on that function that's going bad. Let's walk through it again. We set current is equal to head. Looks like we've got some debugger type information that we can have in here. Looks like we have our watch category navigator. We can add a watch, I believe, new watch. And now our watches show up. So I am gonna add a watch for current. We've already got one. I'm gonna delete all of these because it's been a pain in the butt. Okay, let's do this. Let's add a watch for current. One for counter. No, one for head. And then one for last. That's what's actually really giving us, something here is giving us problems. All right, current is equal to head. So the new one, current, is going to be signed equal to the head. Okay. Yep. 47. Okay. Okay, then current, because in current it's pointing to the head. The head's next is there, but now current has a next that has the 1 in it, and it's next. You see how I'm breaking this down? It's got the 2 in it. And it's next. That's where it goes null, and it has nothing. So what we should be doing is the one right before. That's number 95 here. The value, and that's inconsequential, but let's just say that that's where it exists, that it lives. That's the address for it. I want that to be the one that's being deleted, so that its previous next is going to null. Kind of like this guy is going to null. This guy's got to go to null. So I need current's next to be set to null at some point. And that's what I'm doing right here. So current now goes and points to 95. Okay. Where's head? Okay, head is not in the picture. Okay, current. Where's current now? We're done with the list. We're pointing at 95. That's the 2. So we just need to set its next to null. We need to have this. Or is it this guy? Yeah, 2 is the one that we need to actually delete. Okay, now oh. Yeah, this is going to be a tricky one. I can see there's problems. Okay. Well, that was driving me insane. And sure enough, it was the fence post. This has got to be -2. Because it's already -1 behind. And if we want to be behind, we got to do -2. And that actually stops it so that current is pointing to the very last one. So that we can set current's next to null and reassign last to current. And we've got a working generic linked list that can handle any object available by using boxing and unboxing. It doesn't use the templates like the provided linked list. So then how do we put anything in there? And that is when an insert front happens, you're sending an object, so you got to box the object up as an object, as the object data type. And then we can box it as an object even though it's a customer. So now what I'm going to do is I'm going to go into new Java class. I'm going to call this customer. And we're going to put inside of it string first name, string last name, int ID. Very simple customer. And I'm only going to build out the accessors for the last name. You know, this will actually, I'm not even going to do accessors. That's for you guys to finish up. I'm going to overload the constructor for arguments. Let's see if I can do this. I think I can do this. Okay, so this one's going to be a little bit of a problem. So I need to actually say this dot in that time so I know exactly what I'm actually signing there because they're you know, first and last is fine because they're different words. Okay. So we have a customer class. Let's do the Java toString method. It's been a little bit just so that we can print this. Java toString override. I always forget how to do it. So I just grab it and use it. This is so that I don't, we can be kind of simplistic with this. First plus a space plus last, and then another space with ID in it, and then we add in plus this dot ID. Okay, this will be this dot first name. And this will be this dot last name. So yeah, I figured I had some problems here. What am I missing? Oh. Yeah, that was it. Yeah. Just have the one constructor. Yeah, and I had a string problem here with, I needed to use capital S for string. Yeah, little things. Always the little things. All right, so now. Okay. 412, 41. We have a customer. Let's start doing customers. Okay, let's box it up and put them in our list. So we're going to go over here to our runtime. We're going to get rid of all this. And I'm going to say customer C1 equals new customer. And then I'm going to pass that stuff in. Did I do first name, last name ID? John Doe 12. Okay. Jane, Dan. I'm just making stuff up. I'm just throwing stuff in there. Let's do one more. Okay. Okay, now let's go look at customer. Oh, it's ID. Damn it. Okay. Fixie, fixie, fixie. There we go. Oh, C1, C2, C3, C4. And then what we'll do is we will put these guys on the list. Manager dot add front, and we'll do C1. Now, some languages you may need to do this. You may need to cast it to object. And this is called boxing it. Let's see what Java can do. And also the print method, that toString, and why we overrode toString, because it's going to be easier to, because it knows to call the toString method when we do a print of a customer. Every time we do a system.out of the customer, it knows to call that toString method to print the customer. That's another reason to override the toString. All right. So that means then we can, if this is going to work right, then we can just do a print. Let's see how well things kind of move around. And let's do this, manager dot print. Might have to tweak some things. So the error I'm getting is from this print function, and the fact that I hard-coded integer j there, which I should not have done. What I should have done is just called the print of get data. So this would be boxing it, but what we want to do is we want to unbox it with a customer, or actually let's just create an object. You know, actually right here we can just print the data directly, then we traverse, because this is printing the whole list. So we print the data in the list and then we traverse. That way I'm not hard coding any values, because we were doing things with the integer, now we're doing things with customer. And this is actually more, this right here, because we're using straight up object and trying to get it to box and unbox properly, and because we're calling this print method inside of the linked list. And so we're not telling it how to print a customer, but actually we are in the toString method. So let's see if it works. Oh my God, look at that. It worked. And that's the beauty of Java. Everything can be a freaking object. You don't need templates, but that's fine. I don't know why they built their linked list using templates. There was a big old thing about it, but they might have found something where it breaks. That's possible. All right, so this is boxing, unboxing, printing, simple data types, or advanced data types. All right, that takes us through creating our own linked list, boxing and unboxing. We got our own customer that we're working with within our list manager. Our list manager is properly using abstract object so that we don't do templates. And then we got our node, our manager, and our customer, and then of course our main that tests everything. Now you guys are probably gonna put this in a loop, you know, that'll create 50 customers, something like that. You can iterate the ID, you know, and just throw junk in there. I don't care. Just instantiate 50 of them, throw them in the linked list, print them. That's it. All right, guys. Take care. Bye.